Hello everyone, welcome back. My name is Hardeep and we are at the Kubernetes show. So this week I'm working on our Kubernetes course and we are still covering the core concepts. Last week on June 7th, I recorded a video that talks about some details for pods. And today I have this link to, and all these links, we are covering namespaces, resource isolation, replica set and deployment, labels, selectors, and annotations. So these are few things that you will get during the exam. You should have good understanding of these. And without further ado, I'll get into the very first link, basically, which talks about what makes up a pod, and it also goes into some details on what is the role of a namespace. Right. So smallest unit in Kubernetes is a pod. Pod is nothing but it's a kind of wrapper around container, and you can have more than one container inside. I talked about in a container sidecar containers in my previous video. If you have not watched it yet, go to this one and watch it. And next is a role of Linux namespaces. So namespaces are a way to kind of isolate processes in their own areas so that when a process runs, it feels like that's the only thing it can see, that's the only thing exists in the universe. So it is able to see, for example, if you share PID namespace, you'll see within the container it can see only itself. It can see process of its own only, right? Otherwise, if you run a container, generally what happens within that container, uh, you should be able to see all the processes. For example, if we say, hold on, let me check if I have my multipass cluster running. And yes, it is. So let's get into one of the nodes. Let's get into maybe in this one. Multipass shell. Oh, if you don't know how to get this multipass running, I would say go back to this one and click on Kubernetes, and inside this you'll get these three, and there are videos also inside them. It talks about how to set up your multipass. Not wasting any more time on that, getting into the Linux namespaces. So what I was trying to show is, if I get inside Linux and I do PSEF, you see there are so many processes. So if we see WCL, there are 129, right? But when you run a container sees its own namespace only, right? That is what the PID namespace does. Network namespace, it ensures it gets a IP and it is kind of isolated from others. For example, on one node, you want to run a pod that listens on port 80. Now the problem is, if you have a very small pod and it need to run on port 80, and you want to run 10 other pods and they also need to run on port 80, there'll be a port conflict. It will not let the service start. What's the solution is, we put our services in their own namespace. So within their namespace, they can have their own port 80, right? So in a way, you are able to run more processes on a machine and still have those processes listen on port 80, right? That's just one example, right? Then mount point pod can have its own view of mount points rather than seeing what is there in the underlying file system. So when I get into a node, do DFH, you can see it is showing so many mount points, so many file systems. But if I say k get PO, let's see, do we have any parts? Yes, we have. KEXEC IT, get inside this part, and Let's see if it will let me. Now I'm inside the pod. If I say psef, it says ps not found. It doesn't have even ps. If I say mount, you see it shows so much, but look at this. It says overlay is slash and it comes from container D. You can control all this. For example, dev SDA, it is SDA1 is mounted on host, SDA1 is mounted on termination log, host name. All this tells you that this is all kind of overlay file system. It is created by your container D, which is the runtime environment uh, used by this node, right? So, and you want to see processes and you don't have, for example, your ps, right? So how do we see that? You get inside proc is the live kernel file system, but if you do ls, these numbers are kind of processes. And if you go inside one and you can do lsl, and there will be a cmd and you see or exe, right? And you can see it is nginx. So pid1 is nginx in this. If I get out of that pod, and let's find out where that pod is running. Okay, k get pod hyphen o wide, and we were inside this pod b9 bf. Okay, it is on cube worker 2 k multipass shell. Get inside that node. If you see here, I was looking at when I was inside the container, I went into proc and one, and inside one, we looked at exe and it was showing user sbin nginx. Now I'm at the machine which is running that pod. If I do proc, you will immediately notice there are more directories. On top of that, if I do proc 1 and exec, you'll see it is systemd. It is not the nginx which we saw here in this case when I was inside a container. You can run a command called ctr, and if you do ctr space, it kind of gives you help hyphen n namespace, and it takes as kate s.io and then list. What was that? Hyphen c. C is for containers. You can see here it's a c, then container list, and you can see it is listing all the containers that are running inside that node. How do I even see where that particular container is running? For example, we were inside this container. Let's see, general ctl hyphen u container d grep hyphen I. Let's see, and it gives me this UUID or this sandbox ID. So list grep hyphen I. If I grep for that sandbox ID, I know this is my container, right? And now I can, of course, this is not needed for your exam, but still this is for your knowledge. um, see info, we are looking for information of that container, and if I do see info, it is kind of giving me all kind of insights. It's running sandbox, it is what option it is running, what overlay file system it has created, area where it talks about namespaces. Yes, right here, right, namespaces. So let's try this, and you can see what I'm doing is running JQ and querying the namespaces. You can see it is showing different namespaces used by this particular container. And all right, I won't spend too much time on namespaces, but you can see, I have provided kind of detailed documentation. If you want to learn more about, for example, MNT, it tells you what it means, PID, and there are many namespaces that kind of work together to make a namespace for container. And this is all helping together to create a pod and in kind of larger context run your Kubernetes cluster, right? And I provided kind of summary here. There is another similar concept of namespaces in Kubernetes. So Linux namespaces versus Kubernetes namespaces, you need to understand Linux is kind of OS level. As we saw, we went inside one worker node and we saw the namespaces that are kind of shared by with this particular pod, right? And in Kubernetes, namespace is a kind of logical partitioning of your cluster. Within namespace, like in Linux namespace, you don't see processes from other containers. We have something similar to Linux namespaces, a Kubernetes namespace too. Linux namespace, they are at OS level. In Kubernetes, they are kind of logical boundary. It is for pod services. It is kind of enable you to run multi-tenancy environment uh, and organization of your services. One namespace service cannot interact with another namespace unless you provide access to it. But by default, when you are inside namespace, you are able to kind of see pods services within that namespace. Scope, it applies to processes and resources within Linux kernel. This applies on Kubernetes because it is a Kubernetes namespace. Both are two different things. Um, Linux namespace, isolate containers at the OS level, right? So you are running two containers, they will run in their own namespace. In Kubernetes, you are isolating different groups, services, resources in a namespace. So how do you see it? We saw one example where I was running some commands. It was showing a pod and its namespace. But if you want to run, for example, a pod in a particular namespace, you always specify either hyphen hyphen namespace or hyphen n. For example, here dev and there in n pod, right? Kubernetes namespace allows you to have basically permissions, access, restrictions, resource control policies, all those things you can do on Kubernetes namespace, right? Uh, this is kind of very high level on namespaces. You will have to create namespaces during your exam. So the best way would be when you are sitting in the exam, they'll give you instructions, but anyways. So let's see, if we see there are a few namespaces. If I want to k create ns test, and if we do this, you can see there is a namespace called test, right? And k get po. When I'm running this, I'm running this in default namespace, right? But if I say k hyphen n test, now what I'm saying is go run and get me resources from that particular namespace. Kns test get all. There is nothing there. But if I remove n and test, you can see I'm running few things in my default namespace. There, if you want to see all the resources in all namespaces, you can do hyphen capital A, and you can see it is showing you first thing as namespace, and that is how you see what I'm running inside uh, my default namespace in kube system. And you can define permissions. As I said earlier, you can define permissions, you can set quotas, you know access on namespace level. If you want to delete a namespace, all you do is k delete ns and name of the namespace. It takes time if there are more resources inside it, but at the same time uh, there are some finalizers. It is something in Kubernetes. So these finalizers do go and clean up resources from, there are maybe pods, replica sets, and, things that it need to clean up. It does that. Also need to clean up the IP spaces from the nodes and all. So deletion sometimes can take time. You can do a force delete. You can add a timeout value also there. So which is kind of grace period. You can say grace period 0. Since I have deleted it, it won't say anything. It's gonna say that it doesn't exist, it was already deleted. That's the idea of a namespace. So k get ns, we have only default namespaces. This Cilium created. If you don't have Cilium running, then you'll see all these only. But since you have deployed using my multipass script, you should see a Cilium namespace too. So this was kind of an overview of what namespace is, how resource isolation works. And next is the replica set deployment, label selectors and all. Before I get into it, I also want to show you something, what makes a pod. And it within the pods there is something called a pause container. It is not again part of the exam, but it is part of your daily life. When somebody asks you a question, you should be able to answer. um, so the pause container is a kind of high level thing which holds the namespace, IP address, storage that you have allocated for containers. And this pause container comes into life. I think I have described that pause container in this one. Let's see if no, not in that one. I think it is in this one, pause container, right? So it is IP address, port, storage space and all that. It kind of retains all that. I think we did see when I was running some commands on the worker node. And let's see if we try to hold on, let me try to go back. And when we ran this list, you can see there is a pause container running almost everywhere, right? But for this one, the container that we were running, let's see, instead of info, and we see only one thing running. We want to see that pause container which we were talking about, right? Okay, the pause container. How do we see this pause container? Right, so k get -o wide. This tells me on what node this particular pod is running. So I do multipass shell, get into that, become root, and then ctr-n k8s dot io task list. C list. Look at this. Okay, so let's do task. If I could write list, right? Now, how do we know what that pod is? The pod we talked about, this guy, right? What is its name or what task it is assigned to? Mm, So I run journal ctl-u container d and grep, and it tells me this is the deployment and this is the sandbox ID, right? Now this sandbox ID, when I run list and I do grep, you can see a number, and number is PID. So I do PSEF grep I, and it tells me it is pause container, right? ps3 hyphen, I think gp. Let's see. Yeah, it gives me that only, but let's see if its parent container can give me something. Okay, it tells me that there is nginx running and how it is, connected to that particular thing. And now it is showing me all the child processes too. So idea here is your pause container is the parent for processes that you are running inside containers. But how do we see if that was a kind of single pod, right? So I got the same deployment. If I see right here, right, the pod name, if I say oh YAML and then scroll bit up and look at this spec containers, I have only one container that runs, and that says go and run nginx, right? Now I hope this should be able to clarify what that pause is. If you are running more than one um, processes or containers, more than one container inside a pod, this pause container act as parent for uh, processes. So the IP address for the pod, the storage, all those things are basically assigned to this pause container. When you delete a pod, not only those other containers are deleted, finally this pause container gets deleted. That's how your resources are released. The example or the commands that I ran here should have given you some insights into, what, how to find a pod, where does it run. So to find a pod where it is running, I did a kget pod wide. I got the pod name, I got the worker node name where it is running, got inside that node, and then I did general ctl hyphen u because my container runtime is container d grept for. I could have grept for the pod name, but anyways it gave me a sandbox id. And when I ran task list and grept for the sandbox ID, it gave me a PID. From that PID, I was able to see, what processes are running inside it, got out of it, described that particular pod, and we could see that pod has only one container. So now this should have given you enough insight into what a pod is made out of. Uh, if I show you one more thing, um, one more time, and that was when we were looking earlier, the namespaces, right? So I ran this command ctr-n ktsio container info. I'm looking at that container, and then with JQ I'm showing what namespaces are associated with that particular um, container. All right, now what is a replica set and what is a deployment? Till now we have been looking at only uh, pods. But what if I want to run 100 pods, 1000 pods? You don't want to keep creating these pods with the YAML files manually. It creates a challenge because you don't have kind of controls around managing how many it should run. So there are some higher level constructs that are kind of replica set and deployment. I provided some distinction between those two. Initially, Kubernetes had replica sets only, but then deployments came along. This provides you lifecycle management, which is kind of not possible with this, very limited available. Rolling update are not supported in replica set. This was one of the shortcoming that was addressed in deployments. Lifecycle management, again, it had limited. This one got even history tracking. I would say read through this. I don't want to kind of spend too much time on it. This is a visual representation of how does it work. When you want to deploy something on Kubernetes cluster, you say go and deploy, go and create a pod. You don't by default or generally create pods. What you do is you create a deployment. Deployment in the end behind the scenes creates replica sets. So if your application was version 1, it'll create maybe replica set of v1 and then run two parts. Tomorrow there is an update in deployment, you change the image, it'll make another replica set of version 2, and then you update to version 3, it'll create another app. Now this is kind of providing you history, it is providing you lifecycle management, it also provides you ability to kind of rolling update one at a time from version 2 to version 3. So many features were enabled with the help of deployment. Replica set monitors the pods and keep replacing if pod dies for a particular version, but deployment is kind of higher level construct which gives us more control over pods, right? And how do you kind of do a replica set? I have provided some examples here. Let's create a directory. Inside that directory, virs.yaml, and if I paste it and k create hyphen f rs, k get po, if you see it's creating something. So if I say k get rs, and it is giving me, there are two replica sets. This is from a deployment. So kget deploy, if you see, that was Nginx deployment, and this is front end, right? In this document, I have also shown few things that, some commands that you can run to kind of review your resources, read about them. Again, k events hyphen hyphen for rs, and then front end, you want to see only that particular thing, right? Okay, this is the deployment that you see running, and I did all this. And yes, this hyphen hyphen show labels, this is important. During the exam you'll have to use this. So labels help to kind of categorize your pods. You are just putting a label on the parts. You are saying this is a front end pod, this is a Nginx pod, and this hash thing, this comes from your deployment with the help of replica set. If version changes, this hash will change, pod template hash will change, right? That's how it keeps control. But anyways, now whenever you want to kind of list pods only for a particular label, what you can do is hyphen L and Nginx. So if I don't do hyphen L, what it gives me? It gives me everything. It gives me even Nginx parts and front end parts. But I want to see only Nginx. Then you say hyphen L Nginx. You can, do multiple. You can do comma and like it is shown here, right? You can do that, but this is just one way of listing your parts, right? There are some details about it, and then finally, how would you scale your deployment? You run simple command. Now we are saying make the count 5. If I say Nginx, you can see how many are running. Earlier we were running Nginx, we had only 3. Now we have 5, right? And hyphen show labels, you can see all 5 are running. This just came 5 seconds ago, 5 seconds ago, here 17 seconds ago, right? So if I want to scale replicas down to again 3 and then show labels, you can see, it's scaled and down, and we have only 3 of them running, right? So that's how you do it. So namespace isolation, um, you can follow this guide and see how your containers are created uh, in different namespaces. Let's say create a namespace and then pod and dev. Let's see, vi pod and dev, and I'm gonna paste this. And now get po. Now this command ran in default -n because we created a namespace called dev, and you can see it says container creating -o wide. It is creating on cube worker 2. And how do you see in a particular namespace? Then I've shown an example of setting quota. I recall seeing this in exam. Again, all these things you have access available. K explain, you can do this resource quota. It tells you everything. But if you don't recall this, just search for quota in official documentation and you'll be able to see. Here we are saying pods will have a hard limit of 2 CPUs. Request number of requests. You can request for 1 CPU. Maximum it could go to 2 CPU. Request is 1 GB memory, but limit is 2 GB. So if somebody tried to create a pod larger than this, that will not work. Let's define the quota and run it, deploy it, and let's see, you can see pods 1 2. You can now create pods and see if it will hit those limits, right? Quota is kind of something special. You don't just see if you run kubectl get kubectl hyphen n dev get all. It will not show up here. You'll have to specifically say get quota, and that's how you kind of see it. Okay, one more thing I wanted to show you. K create quota hyphen h. If you run this, this gives you pretty good help on setting quota. Rather than doing it in a file, you can do it like this also, right? So we are looking for help, and this is kind of imperative way of doing things. If you don't want to kind of apply it, you can say hyphen hyphen. So here is the full command from here to here, and you can say dry run, right? And let's see if it will let me paste hyphen hyphen dry run find hyphen of YAML. I know it did not take it properly because of this. Yes, you can see now it shows me the YAML, the format we created here. Remember, we created this file. It is similar format, but getting created with the create command. And what else do we have? Okay, there are things like labels. You can label pods with the help of kubectl label. You don't really need to run kubectl edit and modify a pod. You can run like this also. You can label a deployment, you can label a pod, right? So let's say front end pod, any pod. We pick up one pod and give it a environment variable production, right? K get po hyphen hyphen show label. And if we see, here is that label. If you want to remove that label, hyphen h. So you can do foo bar this. pod name, and label minus. So env minus, and I unlabel the pod. And now if I show you, label is gone. A similar thing is annotations. Uh, this is what you'll be using throughout the exam. Annotations is not something you will have to use in exam. It is kind of extra information for the parts. There are some controllers, for example, if you are running EKS and you have your load balancer controller that uses annotations. If you have maybe third party plugins, those use annotations. Otherwise you will not need annotations at all. How do you see annotations? You can run describe, and I've given some homework. I would suggest you to go through that and spend some time playing with it, getting your hands dirty. This completes our first section of CKA certification, the core concepts. If there is anything which is not clear to you and you feel like you need more information, either comment on LinkedIn or on my YouTube video, or raise a request on GitHub, pull request on GitHub, issue on GitHub, and I will be able to do a follow up or answer your questions there. With that, thank you everyone. We'll see you next week. Take care. Goodbye.